Hello. So yes, we are now recording our next lecture, which is on nonlinear pricing of monopoly. So let's recall the last lecture where we talked about price discrimination, but a group pricing or third-degree price discrimination. Okay, and we figured out how to do that, what would happen under what that means. Basically, each person in the group will pay some price, which is common to members of that group, but different prices across different groups. And on the assumption that you've solved identification and arbitrage, you can implement that. Okay. What else? We also talked about welfare and how welfare will go up if total output goes up. And we have shown that under linear demands, output will not go up under third-degree price discrimination, group pricing versus uniform pricing of monopoly, of course. So from a welfare perspective, it doesn't matter if it's uniform or profit or group pricing, third-degree price discrimination. So now we're here in nonlinear pricing, and we will talk about first-degree price discrimination, which is forms of personalized pricing, and how this sort of personalized pricing can happen. Let me first share my screen. I forgot to share my screen. And here, let's share my screen. There, yes. So now we will talk about personalized pricing today, and then two-part tariffs, and then block pricing. So we'll stop with personalized pricing first. And then the second-degree price discrimination will come naturally later, but then we'll spend some time first talking about personalized pricing. Because we need to have a good grounding of personalized pricing in order to really understand what's going on with second-degree price discrimination. Okay, so observation, quantity discounts. The more you buy, the cheaper it is on a per unit basis. So with nonlinear prices, price per unit varies with some feature of the buying arrangement, depending on characteristics like consumer's income, the value of time, the quantity bought. The goal of nonlinear pricing is to convert an individual's willingness to pay into revenues and profits. The seller price is closer to the willingness to pay of consumers. Okay, so that's the goal, is to for the monopolist to be able to get more of the willingness to pay, or more of a consumer surplus, transform that into revenues and profits. So our nonlinear pricing is divided to two groups, which is called first degree or personalized pricing, and then second degree or menu pricing. So for right now, we'll talk about personalized pricing, okay? And compare it to, say, third degree, especially, right? Personalized pricing. So in some instances, the monopolist may be able to solve the identification or arbitrage problem, especially for cases when fees are paid after some information has been given by the consumer. So once the seller really knows the consumer, then the identification and arbitrage problem will probably go away. Okay. Now, when that happens, there are two strategies which allow the seller to achieve the same effect, even when fees must be announced in advance. So when fees must be announced in advance, it's possible to do personalized pricing under a two-part pricing scheme or block pricing. Okay, so those are the two things that we will be talking about today, right now in this video. Two-part pricing. The pricing strategy that consists of having a fixed fee, such as a membership fee, that entitles the consumer to buy the good or service, but is independent of the quantity that the consumer buys. So the analogy here is that this is sort of a fixed, in technology, there's a fixed cost of operation, right? Whatever, how much you produce, you pay a fixed cost. In this case, there's a fixed fee. No matter how much you purchase of the good, you will pay a fixed fee. So think about it as a membership to a club, or a fee to access the market, and so on. And then there's a price or usage fee, which is a charge on a per unit basis. Okay. So as you can imagine, because you have a fixed fee, the average price is in fact falling the more things that you buy. Okay, because total fee is a fixed and variable, and then you divide it by total quantity. So total that will drag the average fee down, okay, or the average price down the more you buy. So that's what we were talking about earlier about forms of quantity discounts, right? That on average, your average price goes down the more you buy. Okay, so that's a feature of this two-part pricing. So you've got examples of this: clubs, discount, shopping clubs, amusement parks. All right, so now let's talk about two-part pricing specifically. Okay, so there is a resort owned by a local monopolist. The inverse demand for two types of clients: old, subscripted by O, and young, subscripted by Y. Okay, so quantity I is the number of zip lines for each group I. P is the price per zip line ride. And VI is the maximum amount QI will pay for just one lift ride. So this is the maximum willingness to pay, VI. And the maximum willingness to pay for the young is greater than the old. And here is your cost function to provide Q rides, okay, for both the young and the old. So let's assume that the monopolist can identify each type and prevent arbitrage. Different zip line lifts for each type of client. Yeah, so if you're young, you go here on this lift, and then you're old, you go on the other lift. So in this case, we have the non-discrimination component, non-discrimination solution. And this is simply the third degree or group price discrimination. So what's happening here is that you have different prices per group, okay? And that each one, you're basically solving marginal revenue equals marginal cost. And then this is the quantity for the young, and then this is the quantity for the old, and this is the price for the young, and this is the price for the old. So these are the third degree price discrimination outcomes. Sinulat lang dito yung nakasulat dun sa graph above. And again, this is just an exercise of third degree price discrimination, and I invite you guys to calculate this, and this, and this, and this. Okay. One interesting thing about this demand function, I just want to point it out. It will be easier to sort of do the math or sort of intuit the math. I'm just going to now use the whiteboard. Okay, so I'm gonna try this. So here's your demand, right? So price is up here, of course, and then the quantity is down here. That's the worst Q ever. So this one is V. And then this one is also V. Okay. So when the quantity is 0, price is V. And then when the price is 0, quantity is V. So that's the interesting part of this, and that you can read, because, for example, if this is the price, here's the quantity. Okay. If you recall, I will write the text. Price equals V minus Q. This is also equivalent to Q equals V minus P. So you can read, you can know the value of Q, okay, simply by doing V minus P. And you can do the value of P simply by doing V minus Q. Okay, so that's the cool thing about this. Makes it a little easier, right? And the total volume or consumer surplus, if marginal cost were 0, right? If the price were 0, the entire area under the curve is simply 1/2 times V squared, right? Because this is basically 1/2 height times width times 1/2. Okay. Or if you wanted to, like a square of V by V, and then you're taking half of that. That's the area. Okay. So now let's go back to this one. Okay. Now, this is your price. This is your price for old. This is your price for, this is your quantity for young. This is your quantity for old. Now, I invite you also to use these outputs and these prices and input it to this profit function, because this is just the price minus marginal cost, or in this case, average cost, times this, okay? And then this minus this. So this is just the variable profit, right? Because we have a fixed cost here, okay? So that's sort of the thing that we're ignoring the fixed cost component because we're interested in the short run, right? Remember, in the long run, the covering fixed cost is important. Okay. So here are your profits. What we should notice now is that under third-degree price discrimination, consumers have some amount of consumer surplus, area A, B, D, and E, F, G. So in the plot here, I will annotate. That's this one. Okay. And here, that's this one, yeah? It's the area above demand and supply. Oh, I should erase this. How do I erase that? There you go. Oh, I haven't erased everything. Okay, so there you go. You have that area, which is Vy minus Py, the height, okay, times Qy. Okay, so let's look at that again. Times 1/2, actually. That should be a 1/2 there. So that Vy minus Py, which is this, times Qy. So there should be 1/2 here. There should be 1/2 here, okay, which is indicated here. And that essentially turns into Qy squared. So that's what's cool about this. Vy minus Py equals Qy because of the form of the demand function, right? And Vo minus Po equals Q0. So this is basically Q0 squared. This is Qy squared, 1 times 1/2. And that's this part here. So the point here is, as long as the average cost is, or marginal cost is less than the high willingnesses to pay, then there's still a consumer surplus. So now we actually talk about the two-part tariff. Suppose the resort owner switches to a non-linear pricing scheme. That has two components: a cover charge to enter the resort and additional charge for every lift ride bought. Then you set the entry fee for the old equal to this and the young equal to this. So note what we did. We set the entry fee exactly equal to the consumer surplus for each group at the discriminatory third degree price discrimination prices. Okay. So the old zipliner is charged an entry fee of 8. The young is charged an entry fee of 18, and per ride charge of 8, and the per ride charge of 10 for the young. So again, this is discriminatory because of different prices, yeah. And of course, it's discriminatory because of the entry fee. So zipliners will be willing to patronize the resort since their surplus is not negative, just 0. Since the entry fee is independent of the number of lift rides each zipliner actually buys, each consumer will continue to buy the same quantity as before. And the increase in profit is equal to the sum of the fixed fees. So remember, under monopoly, third degree price discrimination, I should say, of the monopolist, that we have a profit with a charge of 8 and 10. And then now you add 8 and 18. Because you're basically just asking them to pay to access your zipline machine, and then you're asking them to pay exactly the amount to which they are indifferent to pay. So the increase in profit is equal to the sum of the fixed fees. And, well, we will skip this one and go here first. The resort owner can do better by actually reducing the price of a ride, thereby increasing the potential consumer surplus each zipliner has. This permits the owner to increase the entry fees to extract this additional surplus. So the profit maximizing scheme is to set price equal to marginal cost, set the entry fee for each type of client equal to the consumer surplus at that price. So the consumer surplus at price equals MC is the following. And I want you guys to confirm that this consumer surplus here is greater than the third degree price discrimination alone, or even the third degree with the additional fixed cost of the consumer surplus at that value. I can give you a graphical result using this one. So this one actually shows you the optimal, the best two-part tariff, which is to set the price equal to marginal cost. The monopolist gets the entire area above the triangle. So I have two arguments for you. First is that, remember, perfectly competitive markets maximize total surplus. And therefore, this is literally the monopolist getting the entire total surplus. The monopolist gets this one, okay? But under the profit is zero because the price is equal to C, right? And that's just equal, the revenues are exactly equal to the profits here. And then this one, well, there's a fixed cost component, of course, that we're not thinking about. But then this area here is also maximized, okay? So it's in this one, this entire triangle is now pure profit for the monopolist, as well as in this triangle for the old. So I can draw, for example, and annotate on here. Let's draw, where's my pen? Here. Yeah, that's fine. You can draw, for example, the usual marginal revenue is here, right? Pretend that this is marginal revenue. And then this is the price, okay? Okay, so what does the monopolist get? The monopolist gets, I will draw something and change the color a little bit. What does the monopolist get under the situation? He gets this one, right? This entire area here. That's the profit. Well, not the profit. This is actually this is the profit. I should be clear. This is the total surplus. And then the profit, I'll use green, is this one. Okay. So under third degree, without the fixed fee, this triangle remains consumer surplus. This is the profit. Under third degree with the fixed fee, this now becomes part of the profit as well, because this triangle is transferred to the monopolist. But under this maximized two-part tariff, okay, of which this is an example, right? Instead of setting P, you set this price C, and then what do you get? You get this extra triangle here. This is the additional profit, okay? Additional profit from additional profit from optimal two-part tariff. Okay, and then you can do the same thing with this other with VO, and then there's also going to be this triangle here that will give you additional profits from maximizing from doing two-part tariffs. Okay, so we're done with annotating, and I invite you to do it numerically. or using symbols. You can do it, you can compute the profits for third degree with the fees and then compare it to these values here. And you will see that this has to be bigger than those. Entry fees now are the only source of profit. The total profit has increased to the following, which is N is the number of old and NY is the number of young. And then this is the total profit. And then you subtract, of course, your fixed costs. Two-part tariff has the effect that the clients are now buying at the quantity they would have bought had it been priced competitively. The ability to practice first-degree price discrimination leads the monopolies to expand output to the competitive level. The market outcome is efficient and total surplus is maximized. Now let's talk about block pricing. Block pricing, the seller bundles the quantity that he or she is willing to sell with the total charge wished to be set for that quantity. Okay, so let's think about that. He bundles the quantity he or she is willing to sell. So I am willing to sell you like X rides. So this is more familiar to the real world. Right? I'll sell you X rides. And for selling X rides, I'll sell it for like 100 pesos. In the zipline example, the owner sets a pricing policy of X zipline for the price of Y pesos. Exactly, right? Two simple rules determine the optimal block pricing strategy. Okay, you set the quantity offered to each consumer type equal to the amount that the consumer will buy at competitive pricing. Q, where price equals marginal cost. Then set a fixed charge for each consumer type at the total willingness to pay for the quantity identified. In other words, using block pricing, you accomplish essentially this. Since I know the young's demand and I know the old's demand, I know how much they will consume at the perfectly competitive price or at cost. Okay, and then I will say, okay, I will sell you this at cost, and to access all of that, I need to get this entire triangle from you. Okay. So at price is equal to marginal cost, the young client will buy VY minus C lift rides. The old client will buy VO minus C. Why? Because remember, Q equals V minus P. And since P is C, then you just replace P by C, right? Then the total willingness to pay would be the area under the demand curves at these quantities. So the young would be 1/2 V minus C squared plus V minus C times C. Vy minus C times C. And that's just equal to this one. Okay. And then at the old, it's the same thing. And I invite you to look at the graph to see, check why. Applying rule 2, we have the following pricing policy. So old client, you offer entry plus VO minus C, okay, lift rides for a total charge of the willingness to pay of the old, which is what we calculated here, right? And then same thing for the young. Okay. So entry plus this quantity of rides, and then you extract the total willingness to pay. Okay. So the total willingness to pay, just to go back here, that's this one. VO minus C squared over 2. We're basically just copying. It's literally the same one. Okay. It's the same one as the one in the earlier slide. Now, the profit for each type of client is willingness to pay minus the cost of the rides, which is this, right? Which we already calculated. And the VI is different if it's old or young. These amount to offering to the young zipliner, 120 for entry plus 12 zipline rides. For the old, 64 for entry plus 8 zipline rides. You should be able to calculate all of these, okay, from these numbers. Okay, so the quantity is just VI minus blah, 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 blah. Okay. Then you should also calculate the profit. So by entering numbers for this and this, it will give you what the profit is. So I think we have numbers for C. For all of the examples, we're using VO is 12, VY is 16, and C is 4. So all of these redound to actual numbers, which is what you are seeing here. Profit from the young is 72, and profit from the old is 32, based on those numbers. Okay, so two-part pricing and block pricing schemes result in average prices being equal to what you had occurred in third-degree price discrimination. Two-part tariff is block pricing, and average price per lift ride of a client is the following. Okay, so this is the average price, because this is the total charge divided by the quantity, and then you get this. And this happens to be just the price under third-degree price discrimination, which I invite you to go back to. And this is actually plus, not minus. So that's why I did that extra thing there. Now, these lead to two different profits, even though the average price is the same under group pricing and under personalized pricing, nonlinear pricing. Okay, so in linear pricing, the price paid for the last unit is greater than marginal costs, which is how the seller makes profit. While the price charge for the lift ride is sold is equal to the marginal benefit, the price charge for each other lift ride sold is less than the marginal benefit, which is another way of saying that there is still consumer surplus left on the table. With nonlinear pricing, you set the price equal to marginal cost, and the fixed charge converts the entire surplus, consumer surplus, into profit. And block pricing, which is equivalent to two-part tariff, the quantity and total charge are bundled into a package, with the package being designed to extract the total willingness to pay for the X units. Okay. So that ends first degree or personalized pricing. The link between this and second degree is the fact that if you have block pricing here, then you're basically offering a menu or a menu of different packages, right? An old package and a young package. And second-degree price discrimination is all about once the seller's ability to identify different types of buyers or reduce arbitrage among them is reduced, then complete surplus extraction of perfect price discrimination is no longer possible. So you'll have to sacrifice some profit in order to allow consumers to basically self-select into the packages that you want them to go to. So the profits will not be as high as under personalized pricing. But let's stop there, and we'll go to the next video for the second degree price discrimination.